Welcome back. So in this video we're going to be looking at how to characterize the relationship between two variables when they are both quantitative, in other words numeric quantities. So in this example we are going to be looking at the relationship between the lot size of a home and the size of the home itself. So the interior living area of the home. So this is in acres and this is in square feet. So the first thing we want to look at is just a simple scatter plot. So we're going to go to Insert, and we're going to pick this one down here. This looks like a scatter plot. And of all the options here, we want to pick just the basic one, the first one. And actually there was one other thing I should have done first, and that is I should have selected these two variables because it doesn't like it if you don't. So we're going to go to Insert and pick our scatter plot. All right. So this is our living area on the y-axis, and on the x-axis is the acreage. And if we're just looking at purely at the relationship between these two variables, it doesn't matter which one goes on which axis. So in this case, there's not one that we're really trying to use to predict the other one. If there were, then you'd make that choice based on, if we wanted to use acres to predict the living area, we'd make sure we put acres down on the x-axis and living area on the y-axis. But in this case, we don't care about that. If we wanted to switch those, it's tempting to want to go up here and right-click and go to Select Data and switch row and column. I've never been able to get that to work though. So what you would do there, if you wanted to do that, is just switch them. I would take this and just cut and then move it over here and insert cut cells where it's backwards. If by chance they are not next to each other, if I wanted to do acres versus sales price, I could highlight column C and then hold down the control button and highlight sales price. Okay, but I've held down the control button the entire time. So acres and then control, click on the sales price, and then that'll let me do that chart, or that scatter plot. Okay. And then you'd make sure that you added appropriate labels on your axes and on your chart. So what are we trying to get from this? Well, we're just looking to see if there's a trend. Does it look like this data fits a straight line? Does it look like it fits something besides a straight line? If it fits a line of some sort, how tightly does it seem to fit that line? And that's where correlation comes into play. Correlation is something that we did not cover from, I think it was section 3.5, because I wanted to get to scatter plots first. So this is kind of a detour into that section. So there is a numeric way of characterizing the strength and direction of the linear relationship between two numeric variables, and that is the correlation coefficient. That's measured on a scale from -1 to 1. And the Excel function is correl, C-O-R-R-E-L. So let's go ahead and do that, and then we'll talk about what that means. So equals C-O-R-R-E-L, parentheses, and we were looking at between acres and living area. So, and it doesn't matter which one you do first, they're both exactly the same. So we're going to select our first column of data, comma, our second column of data. And then we're going to close our parentheses and hit enter. So when we do that, we get a correlation coefficient of 0.441. Now let's talk about what that means. So we're looking for the strength as well as the direction. So the direction is just the sign of the correlation. Is it negative? Is it positive? If it's positive, it means they're both increasing. If it's negative, it means as one increases, the other one decreases. And I'll show you on these plots down here. So just just the slope. So a positive slope is a positive correlation. A negative slope is a negative correlation. Now the correlation, the other part of that is it tells you the strength. And the strength is a very good thing to know. Keep in mind though that, well, let me just say this. Everybody always wants, what are the cutoffs for what's moderate, strong, very strong, or on the other end, weak? These guidelines are somewhat arbitrary. Every textbook, if they list guidelines at all, will list slightly different ones. Some textbooks just don't want to do it at all because these are not set in stone. Notice I put very, very, very rough guidelines. They're context dependent, for one thing. If you're doing a correlation in the real world, you're going to look to see, you're going to compare it not to this, but to other correlations from similar studies. So if we were looking at, this correlation here that we got, 0.441, according to this, it's moderate in strength and it's positive. But a couple of things. If you look at this scatter plot, it doesn't look like there's a very strong relationship here. If you take out these two data points, this is really, really weak. So you kind of take it all with a grain of salt and look at it holistically. You would want to compare this to, other cities, other markets, maybe not lot size versus living area of home if you're looking at, the auto market or something, but look at other features and how they relate to each other. So on the scatter plot, here's what some of these look like. I just wanted to show you these so that you can get a little bit of intuition as to what the different correlations look like on a graph. This one is going to be very strong positive. This one is very strong negative. So strong correlation means it stays really close to the straight line. And if it's a positive correlation that's strong, it's going to be close to +1. And if it's strong negative, it's going to be close to -1. If it's a little more mild, you can still see the linear relationship. It's just the points don't stay quite as close to the line. If there's no correlation at all that's linear, these are just kind of hovering right around the line. It just looks like snow. Interestingly, this one down here, you can see a relationship, but it's parabolic. And because it follows a non-linear trend, the correlation doesn't show how strong that relationship is. So the correlation coefficient is not going to pick up on that relationship. So it's important not only to do the correlation coefficient, but also to do the graph so that you don't miss something. I put a caution in here that correlation does not imply causation. I think we talked about this before. The only time that you can conclude cause and effect is if you're doing a true experiment. And this data, we've not done any random assignment, no manipulation. All we can do is examine houses that are already in existence. We can't do any assignment there. So this is an observational study, which means we can't conclude that, for example, well, let's see, our two variables here were the acreage, so the lot size and the living area. And I think common sense tells you that the lot size does not itself have any bearing on the living area of a home. There are tons and tons of large homes on small lots and vice versa. And nobody looks at the lot size and says, oh, this is a huge lot, so I'm going to put a mansion on it. That's not really usually what that decision looks like. All right. So next I want to talk about part of this. Another thing you might want to do with two quantitative variables is compare them. Now this only works if the variables are on the same scale. So we can't compare, for example, living area and acres, because living area is in square footage and acres is in, or lot size is in acres. And it wouldn't make sense to compare those anyway. On the other hand, we might want to compare the sales price versus the appraised values. These are on the same units. These are both in thousands of dollars. And it might be interesting to see how close the sales prices are to the appraised values. Or actually the other way around, but how close the appraiser got to the sales price. If you want to do that, then you can do exactly what we did before, which is just a side-by-side box plot. And you can compare some of the descriptive statistics. So the side-by-side box plot, I'm going to highlight those two columns because those are the two we're interested in, sales price and appraised value. And I'm going to go to Insert. And under All Charts, I'm going to pick Box and Whisker. And click OK. Okay, I'm going to give it a better title and a legend and whatever. But from that, you can see that they look like they're almost exactly the same. So the appraisers did a pretty good job. Although I used to be a real estate appraiser, don't get me started on what a racket that is. The appraisers actually just, a lot of them work until they get the sales price. that they need. So we might want the mean, the median, the standard deviation, and the range. And you know how to do that, but we'll do these real quick. Just to review, equals average. Highlight all of those. Close parentheses, enter. Median, so equals median. Highlight our data, close parentheses. I'm going through this quickly because I know you know how to do it, and you can pause the video if you need to. stdev.s for the sample standard deviation. Highlighting all of our data. Well, stdev.s. I get butterfingers too sometimes. Close parentheses, enter, and then this one is max of our data range minus min of our data range. So that's the mean, median, standard deviation, and range. And since I've got all of that referring up there using the relative cell references, I can just copy that over and it does all of them. So that lets me compare the mean, it looks like is a little bit higher. Actually, all of these are a little bit bigger for the appraised values, but not by much. I mean, you're talking about like $4,000 on almost $400,000 house, so that's not a whole lot. All right, so that's it for this part of it. Stay tuned for the last part.